Okay, guys, so I need you to make sure you're paying attention closely because I'm giving you directions also for the calculator when we do this. So when we solve with matrices, one of the biggest, most useful things for matrices is to solve systems. Like we were solving things like this example in the last several weeks. You guys had to solve this and you use graphing or elimination or substitution. But I'm going to show you a way that you can use matrices and that will allow you to solve it even easier. So we have to separate this system as it's written right now, separate the coefficients. And the coefficients, if you are not sure, are the numbers in front of the variables. So I'm talking about the 2 and the -3 and the -5 and this +6 right here. So those numbers make their own matrix. And just like 2x minus 3y is one equation, those go straight across here together in the first matrix. And then underneath them are the coefficients -5 and this +6. So you basically just imagine that the x and the y aren't there and they're removed. And you would have 2 and -3 across the top, and you would have -5 and 6 across the bottom. So that would make what we call the coefficient matrix. Then, because you have the variables x and y, you do have to represent them. So we put them vertically in what we call the variable matrix. You have to write it down. It might seem silly, but you put a multiplication sign and separate the coefficients from the variables, and that sets up that side of the problem. Then you do need a matrix just for the answers to the problem. So 4 is the answer or the what it equals for the first equation, and -7 is what the second equation equals. So if you look at it, you have your 2 and -3 across the top, -5 and 6 across the bottom of the coefficient matrix. You separate your variables out and make them into a multiplier of the variable matrix, and then you set it equal to the constant matrix. Now, what you do with that information I'll show you in just a minute so that you can then solve it and figure out what those two variables equal. So first thing we want to do is practice setting these first couple up. So if I set the first one into a coefficient matrix, again, pretend like you can't see the variables and you have -3, you have -2 across the top, and then you have -6 and +12 along the bottom. That's going to multiply by the variable matrix, which is xy. And you do those vertically. And then what it equals to is 23 for the top equation and -18 for the bottom equation. So the beautiful thing for this is that we can set up and solve for more than just two variables. So in this case, you can see that you have x, y, and z. So when we set this one up, we're going to set all the way across. Since we have three variables, we need 3 rows, 3 equations. So we're going to basically have a column here for x numbers, and then this will be the column for y numbers, and this will be the column for z numbers. So coefficients for x would be 4, the coefficient for y is -2, and the coefficient for z is +3. For the second equation, your coefficient for x is -5, your coefficient for y is also -5, and same for your coefficient for z. Now, in this equation, notice there's no x here. So you have to assume like there's 0 x's. So that means in this x column, remember this is the column for x's, you're going to put a 0 in that spot. And then since this is the column for y coefficients, you put a 5 there. And this is one that gets messed up quite often. That's a -z. So you need to remember that that represents a -1. Then we're going to multiply. The order of these went x, then y, then z. And so you put the variables in the variable matrix in that order. And then the answer matrix is -4, 30, and -13. Okay, so if you go down here to this next one, it says Cody and Megan are setting up matrices for the system 5x plus 7y equals 19 and 3y plus 4x equals 10. Are either of them correct? Now remember that you need to have like a column for the x's and a column for the y's. So you want to check that this represents a column of x numbers. Same thing for Megan over here. Okay, so 5 Cody has is an x coefficient. That's right. He also has 7 as a coefficient for y. He has that. But then on the next one, if you look, Cody has 3 under the x column. Now, the coefficient for 3 goes with the y's, so these two he has switched. So you have to be really careful that you pay attention to the order that it's written in the equation as well. Now let's see if Megan did it right. So she has 4 for her coefficient of x and 3 for her coefficient of y, and then she still has 5 and 7. So Megan is definitely the one who has this right. All right, so to show you how to solve for them, we're going to set these up again. So really quickly, let's just set it up. We know it's going to go 3, then 4, because that's my x, then y. My x number is 2, my y number is -5. Whoops. Then we're going to set up my variable matrix is xy, and my answer matrix is 11, -8. So here's your directions right here. And they're pretty simple. They're pretty cut and dry. If you look at what it says to put this coefficient matrix is always going to be matrix A. The answer matrix is always going to be your matrix B. That's very important. So constant means the answer, what it was equal to. Okay, so in that case, and when I say answers, I mean what the equations are equal to. So it's probably, I'm going to erase that. I don't like calling it the answers. Okay, so the answers in this case are the values for the x and the y. Okay, so right here is what you have to do to solve it. This right here. Okay, so I'm going to type this into my calculator. So everybody open up your calculator and go to your matrix. So second matrix, I'm going to go over here and I'm going to edit this so that A is a 2 by 2. And I'm going to put my numbers in 3, positive 4, 2, and -5. And then I'm going to go put matrix B in. Oh, no. Okay, so matrix B, I'm going to change that to a 2 by 1 and put in my 11 and my -8. And then I'm going to quit out of here. And as it says that I highlighted right here, I'm going to go get second matrix A. So I'm going to go second matrix A. So on my home screen, I have matrix A. Then I have to go to the button that has matrix, but I don't want to push second. I just want to push the button so that it puts a little -1 exponent. And then I'm going to go back and push second matrix and go push, down and get matrix 2, which is B. When I push enter, it gives me the answer for X and Y. So it says 1, 2, and if you look at the order, 1 was X, 2 was Y. So let's write those down. So we have 1, 2. Okay, so let's go ahead and put this one into a system of matrices. So we have 5, -4, 4. So we have an X column, a Y column, a Z column. Then we have -3, 1, -1. And then -3, -3, -1. Make your variable matrix X, Y, Z, the multiplication, and then your constant matrix is 5, 5, negative 11. So we're going to type, like I said before, this first one is always your A, this one is always your B. So pull up your calculator, go ahead and type those numbers in. Let's see, move that over here a little. So we're going to go second matrix, go over to edit. This one needs to be a 3 by 3, and we've got 5, 5, negative 4, negative 4. We've got a negative 3, a 1, and a negative 1. And then a negative 3, a negative 3, and a negative 1. Oops, let's lock that one in. Hit enter. And then second matrix, go back over and then grab number 2. And you want this to be a 3 by 1. And this is going to be 5, 5, negative 11. Lock that in. Quit out of here. Now, remember that trick that I showed you. Since the last problem was A inverse B, we can hit second enter again, and it's going to repeat that problem, but use the numbers we just changed it to. So it tells me that we get, oops, disappeared. We get 1, 4, negative 4. So if we write it the way we're supposed to, we should technically write it as like an XY combination. So like on the last example, would really be best if we wrote it as 1, 2. And on this one, it would be best if we wrote it as 1, 4, negative 4. Okay, so the one thing that I want to point out about this next one when we do it is that you got to pay attention, because again, up here in this spot, you're missing a Z variable. So when we set this one up and we have negative 4, negative 1, 1. The biggest mistake that people make is forgetting their positive and negative signs on the ones, or that they accidentally put in zeros instead of ones. So we have a 0 there for Z. We have a 4, a 2, a 2, X, Y, Z, and then equals negative 17, negative 17, and 6. Okay, so then go set that up in your calculator. Let's go ahead and try to hit pause and see if we can come back and get the right answer. Okay, so I just finished putting in the B matrix, which is my constant numbers right here, my negative 17, and 6. So I'm going to second quit out of here. And let's say I didn't have those up there, so I'm starting fresh. So remember, you would do second matrix, and you would hit enter for number 1 so that you have A, and then hit this fun little X negative 1 button, and then X, you need to go back and get matrix 2. And so your answer should be 3, 1, and negative 4. So if I'm writing that in this manner, I get 3, 1, and negative 4. But remember, I said you need to change that over so it's X, comma, Y, comma, Z. Okay? So you can also use these to solve your dreaded word problems, but you have to kind of make sure that you're doing the same idea as before. When you go set up, you still have to set up your equations. So you would want to go in and you'd say, okay, I have a total of $49, and that's for 6 cheesecakes that are New York style and 1 strawberry. And then I have 12 New York style, and you guys were pretty good at this. So what we're trying to find here is the cost of each one. Okay, so I'm going to go back and I'm going to set this up like a normal matrix. I'm sorry, like a normal system. So I have 6x plus 1y equals 49, and then 12x plus 12y equals 168. So then turn that into your matrix combination, x, y. You have to do this, by the way. You have to do both parts. When you guys get these types of problems, you have to set it up both normally and with matrices, and then throw it into your calculator and go. So go back, second matrix, Let's go over and change A